So, in our previous lecture, we have discussed many concepts like network bits, host bits, subnet, CIDR, VLSM, how to identify network ID, host ID, and we started with the subnetting part, right? So, what we have discussed, let me brief it quickly on the subnetting part, and then we will move ahead with some advanced subnetting concepts. So, we have learned that let's suppose you have the block of this network 192.168.1.0/24. It means that 24 bits are on the network side and you have 8 bits of host ID, meaning 2 raised to 8, which is 256 IP addresses you have with you. Now, if someone comes and asks you that I want the 8 IP address, or you are a network administrator and you want to use 8 IP addresses from this specific network. So instead of using the complete block, such a big block which has 256 IP addresses, you want only 8 IP, so you will not waste the IP addresses. What you are going to do is you will be performing subnetting. So we have also discussed that in each and every subnet there are two IP addresses which cannot be configured on the host, that is the starting IP, the first IP of any subnet, which is nothing but the network ID, and the last one which is broadcast IP, right? So if someone asks you that I want 8 IP addresses, or you being an administrator you want to use 8 IP addresses, so the requirement is you need 8 IP addresses. You will be considering that two of the IP addresses in each and every subnet is of no use, which are network ID and broadcast ID. So what you will do, you will be adding two IP addresses to your requirement, and then you will start to calculate, which is equal to 10, right? So you will start to calculate the power of 2, which should be equal to 10, or it should be more than 10 but not less than 10, right? So if you start to calculate, you will be saying that 2 raised to 1 is 2, 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, and then 2 raised to 4 is going on the higher side, that is greater than 10, which is 16, right? So now it's a time to calculate your subnet and the CIDR. So I told you that the total numbers in each octet. See, IP address is a 32-bit IP address. This is what we have discussed, right? 8 bits in one octet, meaning that in each and every octet of the IP addresses, you will be having a number from 0 to 255, which is equal to 256 if you include 0. This we have discussed initially when we were discussing the IP addresses. So we have come to this conclusion that if you want the 10 IP addresses, then it should be 2 to 4 equal to 16, which means that 16 hosts will be there in this specific IP address. So what you will do over here is, now if you want to write the subnet mask of this IP address, we know that each and every octet, see 24 network ID is already there, so the changes will be on the fourth octet, right? Because 8.8.8.0 means 24 is on the network side. Now you have 8 bits on the host side, which is 2 raised to 8 is equal to 256 IP addresses. From that you want 8 IP addresses. So for the 8 IP addresses, we have considered plus 2 IP addresses which were for network and the broadcast, which is equal to 10. Now you start to calculate 2 raised to power. So which you should calculate up to where you come to this value, or it should be exceeded to this value. Either it should be equal to or greater than. So of course 2 in the power of 2, 10 is not going to come. The lesser one is 2 raised to 3, which is 8. So you will say 2 raised to 4, which is equal to 16. Now, from these values, from which value? From this answer, the power which has come from this, you will calculate the subnet mask. Okay, and this power value will help you to calculate the CIDR. So how it will go? You already have 24 on the network side, so you will simply say 255.255.255 dot. This 16 has come, right? So you have to calculate the subnet mask. Total numbers in each octet is 0 to 255, meaning total you have 256 numbers, right? So you will be subtracting 256 minus this 16. 256 minus 16, which is 240. So this is going to be the subnet mask of your network. And if you want to calculate the CIDR value, you know that total you have 32 bits, right? So this power you have to minus 32 minus 4, which is going to be 28. It is very much clear now that you will be having only 16, you will be having 16 IP in this network, and the IP address will start from 192.168.1.0 slash, you can say 28, or you will say 192.168.1.0 slash, sorry, subnet mask 255. I will write it down over here. 255.255.255.240. And if you want to know the range of this IP address, it is going to be 192.168.1.0, which is the network ID. 192.168.1.1, the first IP address in this network. Then it will be 192.168, second last will be 1.14, and the last broadcast IP of this subnet will be 192.168.1.15. Is it clear? Any questions, any doubt over here? From this power which you are calculating, from this here itself, you will be coming to know the subnet mask and the CIDR. The answer which has come, you will be subtracting it from 256, and that is going to be your subnet mask, and the power value you will be subtracting from the 32 bit, which is going to be your CIDR value. Now from here, subnet mask, you can also say that, yes, or from CIDR you can say that 28 means 28 is on the network side, and the 4 bits are on the host side. Any questions, any doubts over here? So let's move ahead. Now everyone knows that in total we have 256 IP addresses. To the IP address in each octet we have 256 numbers, right? We have 256 numbers starting from 0 to 255. Everyone knows this, right? Now the customer comes to you. I have one block of 192.168.1.0. Okay, 192.168.1.0. This is my network. Now someone, a customer comes to you asking that I need 256 IPs for my requirement. The customer says that he need 256 IP addresses for his requirement. So in this case, listen properly. You know that in each octet you have 256 IP addresses starting from 0 to 255. So over here you already have 256 IP addresses. So from this block, what will be the CIDR value and subnet if the customer need 256 IP addresses? 192.168.1.0/24. Will it work for him? Will this subnet suffice the requirement of 256 IP addresses? If you give him the subnet, will this work? Will the customer get 256 IP addresses? Please put in the chat box. Will this network be enough for the customer's requirement of 256 IP addresses? Because in each octet we have 0 to 255, right? Which is 256. So if I am writing 24, meaning that you have 24 bits on the network side and 8 bits on the host side. That is 2 raised to 8, which is 256 IP addresses, right? So if the customer need 256 IP addresses, will this subnet be enough to meet his requirement? Please put in the chat box yes or no. Allah says that it will not cover. What about others? Yes, guys, be quick. So everyone is right that yes, this range will not be enough. So now, if 256 IP address is a requirement of the customer, then you will be considering two IP addresses which are network ID and broadcast ID, and it will be coming to 258. So now, if you start to calculate the power of 2, so we know that 2 raised to 8 is 256, and the next will be 2 raised to 9 then, because we need 258 or more than that. So 2 raised to 9, which is going to come as 512. Correct? So now 9 means when you calculate the CIDR value, it will be 32 minus 9, which will be equal to 23. Correct? So you will be writing slash 23. Is it clear? Is it clear? Now you want to calculate the subnet mask, right? How you will be calculating the subnet mask? So I will show you. So that trick which I have shown you now, that will work for class C subnetting. Simply minus this values and all. But over here it will be but slightly different, because that trick will not work over here. What you have to do, 23, right, is on the network side. So the first 16 bits will be 1111 right? Is this correct? The first 16 bits are going to be like this. Then 1111 Then on the third side, you will see that it is one less. If it would be 24, you will write 1111 but it is not the case. It is 23, meaning minus, you have to, one is less, right? One bit is less. So the first bit itself is less. 2 raised to 0 is 1. So you will say 1111 and the last is host, completely host. So it is 0 0 0 0 0 0 0 0 0. Now you have to calculate, this is going to be 255.255.254.0. Is it clear? Is it clear? Now, moving ahead, if the customer requirement, if the customer requirement, one second, if you have this block of network, okay, 192.168.1.0, this is a block. Now, if the customer requirement itself is 520 IP addresses, 520 IP address is the requirement, right? Now, if the 520 is the requirement, so you start to calculate the power of 2, and we have seen just now, sometime before that, 2 raised to 9 is 512. Of course, the very first thing what you're going to do is the basic thing you should not forget, 520 plus 2 is equal to 522. So you start to calculate the power. 2 raised to 8 is 256, 2 raised to 9 is 512, and then 2 raised to 512, which is less because your requirement is 522. So what you are going to do is 2 raised to 10, which is equal to 1024, right? Now, now CIDR value you can calculate because you have to simply subtract the power from 32, right? So the CIDR value is going to be 192.168.1.0 slash 32 minus 10 is 22. But you have to calculate the subnet mask, right? It is saying that 22 is on the network bit. 22 is on the network bit. This CIDR represents the network bit, right? So it is saying that 22 is on the network bit and 10 are on the host bit. The host are 0 always, right? So you will start. The first octet will have 8 bits, which is 11111111 dot. Another 8 bits, 11111111. Then you have 6 bits. The third octet, 16 is already there, right? 8 plus 8, 16. The third the third octet will be 6 bits, 11111100. The remaining two are 0. And the final, the fourth bit is 00000000. Now, if you start to calculate, this will be 255.255 dot. How much this will be? Yes, anyone, please put in the chat box. How much this is going to be? 11111100. 252. Ahmed is right. 252.0. This is going to the subnet mask. Now, I want you all to calculate the CIDR and the subnet mask. I have the requirement. You have the network block 192.168.1.0, and my requirement is I need 1024 IP addresses to be configured. Please calculate the CIDR and the subnet mask for this requirement. You have 5 minutes to complete this task. See, this was a network block 192.168.1.0, and my requirement was I need 1024 IP addresses. Is it proper now, or still it is breaking? There was some issue with my mic, right? So is it okay now? Yeah, that's good. Thanks for the confirmation. Okay, let me repeat again. This was a network block which I was having 192.168.1.0, and my requirement was I need 1024 IP addresses. So what I am going to do is, very first, the basic concept I will not forget. I will say 1024 slash, sorry, plus 2, which is going to be 1026. Now, if I start to calculate the power of 2, it is going to be 2 is to 11, which is equal to 2048, meaning usable host or usable IP will be 2046. Now, CIDR is going to be 32 minus 11, which is equal to 21. So you will say that 192.168.1.0 slash 21. Now, when you start to calculate the subnet mask, it is going to be 1111 8 bits over here, dot 8 bits over here, dot 5 bits over here, dot all will be 0. Is going to be 255.255.248.0. You know how to how this 248 came. I have shown you earlier. I don't need to show you again. But one important thing, remember, no one told me. I was purposely writing this again and again, and no one told me. I told you the basic concept. The IP address without the subnet mask or without the CIDR is not a IP address. It is simply what I can say. It's simply a number. So when I'm saying that 192.168.1.0, and if I write 24, of course the calculation which we have done will not work. It is totally wrong. So it is something like slash 16. This was the big subnet mask. And you know that if I'm writing slash 16, how many hosts will be there? 2 raised to 16 total hosts will be there. But I don't need so many hosts. What was my requirement? I only need 1024 IP addresses. So we have done this. Now we have understood classes, right? Class A IP address, Class B IP address. But one important thing which we discussed in last lecture is classless concept, right? Now you can see over here that although the IP address belong to Class C, but you can see it has 16 bits on the network side. So earlier it was there, the classful concept was there, but now that is not the same. Even on Class A network, you can do Class C subnetting. Now what we have done on Class C Class C IP address range, we have done the Class B subnetting. Is it clear? That's a good question, Ala. I was supposed to come there, but it's very good. Now, Ala has asked a very wise question saying that what is going to be the IP addresses. So, see, this way it will go, Ala. Now, for example, you have 192.168.1.0 slash 16 network, and you were looking for 56 IP addresses. You was looking for 256 IP addresses, and for sure 256 IP addresses mean that plus 2, which is equal to 258. Now you start to calculate and you say that okay, 2 raised to 9 comes to be. I'm not going in detail. Huh? You already know what is going on behind this, which will be 5 and 2. Because 2 raised to 8 is 256. 2 raised to 9 is 5 and 2. So you will say that 192.168.1.0 slash 23. This is something going to be the CIDR value. And when you talk about the subnet mask, you will straight away calculate from here 255.255.254.0. How this came, you know that, right? Now, talking about the IP address range. See, it will start like this 192.168.1.0. Okay, 1.0, and 192.168.1.1, then it will be going up to 192.168.1.255, correct? And then next IP is going to be 192.168.2.1. Just hold on one second, I'm getting one call. Okay, so it will be 2.1 and it will go up to 192.168.2.255. But remember over here one important thing. Remember that this scheme itself is not correct. Why? Let me tell you. See, in class B subnetting, the third bit, the third and fourth has a host IP, right? So actually, it is going to start from 192.168.0.0 slash 16. So it will never happen like it will start from one. Either it will be from zero or it will be like 192.168.2.0, something like that. So in actual, the subnetting will happen over here on this block 192.168.0. Always remember that if someone asks, and this is the question also sometimes comes 1.0, this will not be a legitimate IP address. And even if you try to configure, if even if you try to configure this network, it won't work for you because this is something like this. It is going to come 192.168.0.060 slash 16. And now if you do the subnetting, one second, 192.168.0.0 slash 16. And now if you do the subnetting, so the first bit will be 192.168.0.0, which is going to be slash 23, which is going to be the network address. Then you will have 192.168.0.1 slash 23, the first usable IP address. 192.168.0.2 slash 23, second usable address. And it will go like 192.168.0.255 slash 23, 192.168.1.1, sorry, 1.0, 1.0, then 192.168.1.1, 192.168.1.2, and the last one is going to be 192.168.1.255 slash 23. Is it clear, Allah? Your question is answered. Okay. Now, moving ahead with the discussion, we have completed the subnetting part. You can try more examples on your own, and if you have any questions, please feel free to ask anytime during the upcoming classes as well, because subnetting is an important topic. I have shown you the trick for class C subnetting to find the subnet mask, but that will not work everywhere, and that is not a correct approach. But yes, it is a quick approach. Instead of calculating the bit and all, straight away you can calculate it. So it's a tricky approach, but not a correct approach. But it works for class C subnetting. This is what we have discussed. Now, what we are going to do is we have a small topic over here. If you will see virtualization fundamentals, we have to discuss about server virtualizations, containers, and VRF. and it is going to be, I can say, the last theory topic and some small topic for around 30 minutes, 45 minutes is this topics which you can see: Mac learning, aging, frame switching, frame flooding, Mac address table. And most probably by tomorrow itself, we are going to start with our core topics. The first topic which is going to come will be VLANs. And from here, actually, your practicals are going to start. Now, let's take a break for 5 minutes, and then we are going to start discussing about the virtualization. We won't be able to finish today, but we will try how much we can finish. Tomorrow, it will be a continuation for virtualization, and we will be finishing the small topics. Let's take a break for 5 minutes. Don't leave the class. You can take a break, and we will continue after 5 minutes. Okay, so let's start. Now, one very important thing. See, whenever I was using that 192.168.1.0/16, that was something. Initially, I didn't use anything. I simply said that this is a block network. Okay, it is a method of teaching step by step. But finally, what you should be concluding with and what you should take with you is the important thing. Then I told that 192.168.1.0/16, because if I write the, see, let me tell you, if I write 192.168.1.0/24 and I say that I need 1024 IP addresses, it is next to impossible because this is having 24 bits of network and 8 bits of network ID. So for sure that will be /16, and from here you can use that IP addresses. A block is there and you can use that IP addresses. Second thing, I have shown you the subnetting on 192.168.1.0, which is practically incorrect. Now, let me justify this as well so that you will have a better understanding why it is incorrect. Now, till now, you have done the subnetting, and I am sure that you would have realized also. Just hold on. Okay. You would have realized that now, let's say, for example, 192.168.1.0/24 is the network, and if I say that I need the 8 IP addresses, so you will realize that, sorry, if I say that I need 6 IP addresses, so the IP address range will be 192.168.1.0 to 192.168.1.7. Now if I say that I need 16 more IP addresses, then it will be 192.168.1.8, and it will be going up to 192.168.1, up to where it will go? 23. Is it correct? Is it correct or wrong? Please confirm in the chat box. Over here, I need 6 IP addresses. I have done the subnetting. Now I need 8 IP addresses. 8 more IP addresses I need. Then in that case, how it will be? The 8 will be the first IP address, right? This is going to be the subnet IP address range. So it goes in a similar way. But one thing you will notice over here. One thing you will notice over here. What is the network ID over here? See, what is the network ID over here? Just hold on. I'm getting one more call, please. Okay. So what I was saying is, in a similar way, you can start doing this subnetting over here. Now, in a similar fashion, if It's 192.168.0.0/16. We have learned how to do the subnetting over here, which you can say class B subnetting, but it is not a proper word. And that's all about the subnetting. Anyone has any questions, any doubts on the subnetting part? I don't think there should be, because we have done a lot of example on subnetting. If there is no doubt, no questions over here, let's move ahead and discuss about virtualization. So, guys, when you talk about virtualization, there are many virtualization OEMs available in the market. It can be Oracle, Microsoft, VMware. There are many OEM available. So they are Oracle, they are Microsoft, then VMware, which is now Broadcom. Broadcom has acquired the VMware product, and even the packet tracer which we are doing now, the lab which the application which we are using to perform the labs, that is also a virtualization software. So what is virtualization? We will be understanding. So there are many virtualization software, and what are the differences in detail we are going to understand, so that you will have a proper insight on virtualization. So to understand virtualization, we are going to take VMware as a base to understand virtualization, and we will understand the functionality. So whatever is there over here in VMware, it will be same in the Oracle, in the Microsoft, or any other OEM who is providing you the virtualization platform. There might be a difference in the interfaces, in the configuration, in the approaches, but yes, when you talk about the functionality, it is going to be same. Here and there, the difference will be there, but the functionality is going to be same. So everyone is ready to discuss about the introduction to virtualization, and we are going to take VMware as the base. So I have one slide over here. If you will see, I have a slide over here, and we are going to cover these points: introduction to server virtualization, then what are hypervisors. Since we are going to discuss about VMware vSphere, so introduction to VMware vSphere, overview of ESXi. What is ESXi? Need of vCenter. And this small topics we are going to cover. Everyone is ready? Anyone has any questions, any doubt, please put in the chat box, or else we'll start discussing these topics. Now, at No Networks, we have a complete course also for VMware virtualization. And if someone is interested, they can reach out to me, and we can have the discussion. Everything will be discussed. But in this lecture, we are going to only have the introduction. So, as I told you that a virtualization itself is a VMware is itself a course VMware vSphere. So the question comes now over here. If someone want to learn virtualization, then in that case, who should learn virtualization? Who should learn server virtualization? This is the question might come to everyone's mind. And let me tell you, the one who has the basic knowledge of server, IP addressing, subnetting, VLANs, what is trunk port. You don't need to have a depth understanding of Windows server or Linux server, but at least you must have the basics of Windows server, the IP addressing concept, networking concept, which includes subnetting, VLANs, trunking, this all. Basic knowledge you should have. So the person who wish to make the career in cloud computing, even if someone is looking to make their career in cloud computing, Then also VMware virtualization, or I can say only virtualization, is very important. They need to understand VMware is a base of cloud computing. And if you go to the website of VMware, you will see that each and every cloud provider is using VMware as the base. Now, do you know who all are the cloud service provider? Please put in the chat box who all are the cloud service provider. Please put in the chat box. Yes, we have AWS, then we have Azure, Google, Oracle, Alibaba. If you go to VMware website, you will see that all of them are using VMware as a base, and that is the reason that if you learn VMware vSphere, it makes you it build up a platform for learning the cloud computing. Now, if someone in the market says you that boss CCNA is outdated one or VMware is no use, remember that without CCNA you cannot learn VMware nor you can do any cloud computing. So CCNA is a base. You must have the knowledge of IP addressing, subnetting, VLAN, whether it is for network administrator or for a system administrator or for a cloud engineer. Now, VMware is a company and they have the product called vSphere. VMware is a company and they have a product called vSphere. And same like Oracle, and same like Azure, sorry, same like Microsoft, we also have a product VMware vSphere, which is dedicated for server virtualization. It is dedicated for server virtualization. VMware vSphere is a product dedicated for server virtualization. Now, we need to understand why virtualization is important, why virtualization has become very important. This we have to understand now. So, what used to happen in earlier days? In earlier days, people used to buy high end hardware. What they used to do? People were buying the hardware. People used to buy hardware. People used to buy hardware from HP, or they used to buy it from some other companies like Dell or IBM. They used to buy the hardware. Then they were installing operating system on this hardware. Okay, and then over this operating system, what they were doing, they were installing application, they were installing database, and so on. Then they will be installing antivirus application. But nowadays the concept has totally changed. You know what will happen? People are going to buy one high end hardware. High end hardware. They will buy one high end hardware. And on that high end hardware, they will be installing hypervisor. Now, what is hypervisor? Hypervisor allows you to boot the hardware. You have purchased high end hardware. You install the hypervisor. It's a bare metal installation. Means it is installed on this hardware. So you install the hypervisor, and hypervisor allows you to boot the hardware using the ISO image. This hypervisor has a capability to boot this hardware using the ISO image. And hypervisor, you don't have to get confused with this term hypervisor. Hypervisor is nothing but an operating system. Like you have a Windows operating system, Linux operating system. Hypervisor is also an operating system. Is nothing but an operating system. Now, when you buy a product from VMware, When you go to VMware, you say that I want to buy a product VMware vSphere. I want to buy this product. So what you will get, VMware will give you hypervisor. Hypervisor. What is hypervisor? It is an operating system that helps you to boot this high-end hardware. They will give you hypervisor, and the hypervisor in VMware is known as ESXi. So ESXi is an operating system. ESXi is an operating system developed by VMware. Developed by VMware. Is it clear till here, or you have any questions? Now, if someone asks you in general that what is hypervisor, see, hypervisor can be from Microsoft, it can be from Oracle, it can be from any OEM who is giving you a virtualization platform. So what is hypervisor? The answer is it is an operating system dedicated for virtualization. What is hypervisor? If someone asks you, it is an operating system dedicated for virtualization. Hypervisor is an operating system dedicated for virtualization. Now, you purchase a hardware from the market. It can be from HP, it can be from Dell, it can be from IBM or any other OEM who is giving you hardware. You purchase this hardware, and after purchasing this hardware, once you have purchased this hardware, you want to do a virtualization setup, you reach out to VMware vSphere, you ask them that, boss, I want the virtualization platform to be established in my organization. What VMware will do is they will be providing you with the hypervisor called as ESXi. They will give you a hypervisor which is called as ESXi, developed by VMware. What you will do, you will install this hypervisor. You will install this hypervisor called as ESXi on your hardware. Once you install this hypervisor successfully, it allows you it allows you to create a virtual machines, multiple virtual machines, not single, I can say multiple virtual machines. It allows you to create multiple virtual machines where you can create Windows machines or Linux machines or any other operating system you can install on this hypervisor. And this concept is known as server virtualization. This concept is known as server virtualization. So I can say that, in short, creating multiple virtual machines on a single hardware is server virtualization. I will repeat, creating multiple virtual machines, creating multiple virtual machines on a single hardware is server virtualization. Is it clear? Any questions? Any doubt over here? See, we have just learned the server virtualization. What is server virtualization? Now, we will stop over here, and in tomorrow's lecture, we are going to move ahead with the remaining topics. We understood server virtualization and what is hypervisor. We will have a short intro on VMware vSphere. We will see the overview of the hypervisor, which is ESXi, and there are some other concepts which we are going to cover in tomorrow's lecture. That's all for today. See you tomorrow.